Okay, so in this video, we're going to learn one of the most important rules in all of this unit and in all of calculus as well. Okay, this is a super useful trick. Okay, and it is called the chain rule. The chain rule. So let's say you had a function. Define a function f of x. Okay? Well, f of x is a, let's say it is a compound function. Okay? A compound function. So meaning it is equal to p of q of x, or p and q are differentiable functions. Okay, you have to say differentiable because you need to have differentiable functions in order for the chain rule to work. Okay? Okay, so f of x is equal to a composite function, p of q of x. Okay? So if you were to find the derivative of this, okay, the chain rule basically says that f prime of x equals the derivative of p, the outer function, with respect to the inner function times the derivative of the inner function. Or if you had dy dx, you have an equation in y, okay? You have an equation y with respect to x. Well, if the equation y was a composite function, a function in a function, they can take the derivative of y with respect to u times the derivative of u with respect to x. Okay? And you can see a little cancellation over here, even though it's like technically not correct. But it's a good way to remember this chain rule. Okay, the chain rule can be confusing, so we're going to go through a couple of problems, okay? So let's have f of x equal to 3x squared plus 5 to the 8th. So obviously you can't really expand this here. It'll take way too long, okay? Nor can you use product rule by, expanding it out as a product of 8 factors, because that will take too long as well. So why don't we use the chain rule? Okay? So what we want to do, okay, is we're going to take the derivative with respect to the inner function. Okay? So you're going to take the derivative. What I mean by that is if you substitute a variable g, let's say, for 3x squared plus 5, you get g to the 8th. So you take the derivative with respect to g, the inner function, okay? So you get f prime will be 8g to the 7th. Okay, it's the power rule. So what you can write this as is 8 times 3x squared plus 5 to the 7th. Okay, so what we did, we treated the inner function as if it were a variable of its own. You don't need to put the g over there, but all you have to know is that you have to treat the inner function as if it is a variable of its own. Okay, so you get this times, well, you can't actually forget about the inner function, so you need to take the derivative of the inner function as well. So you get 6x plus the derivative of 5 is 0. So you get, if you were to multiply this, you get 48x. 8 times 6x is 48x times 3x squared plus 5 to the 7th. Okay? Now, some chain rule problems, okay, you will have to use multiple rules. So this is where taking derivatives starts to get a bit tricky, okay? So let's have this one. Let's do this derivative. F of x is equal to quantity 3x squared minus 2 over 2x plus 3. All of that squared. Okay? In fact, let's just make it cubed. Okay? So, what do we have to do? So first, we're going to take the derivative of the function f prime. Well, we're going to take the derivative of the function with respect to the inner function. So the inner function will just define to be this entire quotient. This will be your inner function. So you're going to treat it as a variable and apply the power rule with respect to this inner function. So you get 3 times 3x squared minus 2 over 2x plus 3 squared times the derivative of 3x squared minus 2 over 2x plus 3. Okay, so now we have to apply another rule. Okay, we have to apply the quotient rule here. We have a division. Okay, so this will be f prime. So that will be 6x times g, 2x plus 3, minus g prime. So that will be the lower function. F is the top, g is the lower function. So g prime will be 2 times f, the top function, all that over g squared. All of that over g squared. Which equals, we can simplify this a little bit, 12x squared plus 18x minus 6x squared minus 4 over 2x plus 3 squared. So if we were to simplify it, the numerator, and put it back in here, get 3 times 3x squared minus 2 over 2x plus 3 squared times 6x squared plus 18x plus 4 over 2x plus 3 squared. So technically this is the derivative. We just found it. However, you might have to simplify it, okay? Because this looks a bit too messy. So what we're going to do is expand the top, okay, of the... So we're going to work on this section first. Okay, we're going to expand this section. And this is just algebraic simplification at this point. Okay, so we get 9x to the 4th minus 2 times 3x squared times 2. So we get 12x squared plus 4. Times 6x squared plus 18x plus 4, all that over 2x plus 3 squared. So we're going to square the denominator, and the denominator is multiplied to get 2x plus 3 to the 4th. And you really shouldn't simplify above this. So this is the farthest you can simplify easily. Of course, you can multiply the bottom and multiply the top, but this is the what you can say the easiest form. Okay, you can leave it there and it will probably still be acceptable. Okay, so let's do another. So you saw we had to use the chain rule and the quotient rule. Okay, now we're gonna have f of x now equal to sine cubed of 4x. So what this basically means, what this basically means is that we can rewrite this as sine of 4x cubed. Okay? Now, this one is a bit weird, but it's simple in what you have to do. So we're going to use the chain rule with respect with respect to here. Okay? So that seems easy. So we get f prime of x equals 3 sine of 4x squared. So that's sine squared of 4x times the derivative of the inside function. Okay? But the inside function has another function inside it. Okay? And that's this one. This will be your second inside function. So you need to apply the chain rule twice. Okay? Meaning that we're gonna have to take the derivative of the outside function, which is now the one in red. So that would be cosine of 4x times the derivative of the innermost function. So that'll be 4. So we get, finally, 4 times 3 is 12. So you get 12 sine squared of 4x times cosine of 4x. So as you can see over here, you get this function by applying the chain rule more than once. Let's do one more, okay? So we're asked to find f of x equals the square root of x times x squared minus 3 cubed. So we're asked to find the derivative of this function, okay? So the derivative of this function, so first we need to use the product rule, since you can clearly see a product with square root of x being our first function and x squared minus 3 cubed being our second. So f of x, well, f prime of x will equal the derivative of the first function. So that'll be x to the 1/2, take the 1/2 out, and subtract 1 from the exponent. So you get 1/2 times x to the negative 1/2, or 1/2 square root of x, times the second function, plainly, f prime g plus g prime. So g prime would be an optimal use of the chain rule. Okay? So now we have to put the chain rule inside while using the product rule simultaneously. Okay? So the chain rule would be the derivative of this function over here, the derivative of this function with respect to the innermost function. Okay? The innermost function. So I'm going to take the derivative of the red with respect to the green. So we're treating everything inside of the green box as one variable. So that'll give us 3 times x squared minus 3 squared times the derivative of the green box with respect to x. Okay, and that will just be 2x. Okay, but we can't forget to multiply by the original function, square root of x. So if you were to tally this up, you would get x squared minus 3 cubed over 2 root x plus 6x times x squared minus 3 squared, times square root of x. Okay? And you can combine this. Okay? You can combine this by and we could do a little simplification if we would like by multiplying both the numerator and the denominator by 2 square root of x. So 2 root x on the bottom, 2 root x on the top. And that will give us x squared minus 3 cubed over 2 root x plus, well, this will make us 12, and the 2 square roots will make another x. Okay, square root times square root will cancel out. It will be square root squared. Okay, so 12 times x squared. It's 2 x's in this numerator over here now. Times x squared minus 3 squared over 2 root x, which equals x squared minus 3 squared plus 12 x squared minus 3 squared. Sorry, this is a cube. Okay, it's all that over 2 x. And this will be our solution. So the chain rule is used basically everywhere, and it allows you to differentiate a more diverse range of functions, ones that aren't necessarily straightforward. And by being able to differentiate with respect to an inside function, by being able to differentiate a composite function, the amount of functions and the types of functions you're now able to take the derivative of will now have greatly expanded.